Okay, Math 1, 8.8, construct a scatter plot. Now a scatter plot is just a graph, and so all we're doing in this one is we're graphing points. So like here we have x, y, x, y, x, y, and so on. Now whenever you're doing these by hand, you can decide what you want your axes to be. I mean, you have to have your x1 be your x's that they have listed here and your y1 be your y's. But how far apart between the dashes, you get to decide. So like for x's, I'm going to do 20s in this case. So I'll do 20, 40, 60, 80, 100. And you see, I looked at the x here to see what would be a good thing for that. You know, maybe I could have counted by 5 or I could have counted by 10, but I kept it simple and did 20. Now we look at the y's. We look at, well, what should I count by here? And I think I'm going to do by hundreds. So I'll do 100, 200, and I think I have to go all the way up to 900, so I'll make this taller. All right, so there's my axes. Now we just go and we plot the points. So first we have the point 6, 810. So 6 is going to be pretty close to the axis. You know, whenever I look here, I'd say, well, this right there, that would be 10. So this would be 5, so probably somewhere in that region. And then just a little bit above 800, so maybe like right there. Whenever we have these huge margins between our tally marks, you just kind of have to guess. You kind of have to just do whatever would make most sense. So then we have 8, 750. So 8 is just going to be a little bit to the right of our point, and 750 will be somewhere in that region. 26, 480. So 26 would be somewhere right there, and then 480 would be closer to 500 than 400. So maybe like that. 590 is almost 60. Oh, I wrote this wrong down here. That should be 60, not 68. 60 and then 180. So 180 is closer to 200, so we'll go somewhere in that region. 67 and then 180. So 67 is about between 60 and 80, close to 70. And then it'll be even with the previous one. And then 98, 220 will be somewhere, well, 220 would be somewhere like that. Maybe like that. So there we are. There's our scatter plot. Number 2, again, we get to do this. I'll go ahead and draw my lines here. Here's my x, here's my y. Looking at my x's, I need to go between 100 and 7,800. So I'm going to count by thousands. So we'll do 1,000, 2,000, 4. All right, there we are. And then we look at the y's. Y goes between 1 and 5, so I'll just count by ones. So 1, 2, well, that was probably too high up. 1, 2, 3, 4, 5. All right, now we're ready to plot. My first point is 105. So 100 is going to be really close to the y-axis, and then 5 will be up here, so I'll put it right there. 2,100 and then 3. So 2,100 is very close to 2,000, and then 3. 4,000 and then 3. Well, that's a nice one. That one falls on my tallies. 5,700, well, that's kind of between 5,000 and 6,000. It'll be a little bit bigger than halfway between. So we'll go like that maybe. 7,700, same thing. It's between 7 and 8, and it's a little bit more than half. So I'll do one like that. And then 7,800 is right next to 7,700, so I'll just do right there. All right, there we are. Number 3. So I construct my axes here. This is my x-axis, this is my y-axis. My x-axis, I need to go between, so I look for my smallest and my biggest number. Here's my smallest number. My biggest number is going to be 97. So I think I might go between 20s again, because I'm going from like basically 0 to 100. 20, 40, 60, 80, 100. And then I look at my y's, and what's my smallest number for the y? It is 20, well, 21. And then I go all the way up to 88. So it almost seems like it would be good again to count by 20s. So that's what I'll do. 20, 40, 60, 80, 100. Now, I don't know if I've said it yet, but there's no wrong way to do our axes here, right? If you were to do 1s or 5s or 10s, you just have to have more paper to do it, right? So don't think that this is a big science that I'm finding how do I mark my axes. You just kind of have to make your decision. And after you do a few of these, it'll be easier for you to see how do you do that. Whenever you're dealing with multiple choice problems, it's really easy. You can just kind of gauge it based off of what their options are. So here we are. The first point is 388. So 3 is going to be really close to 0. And then 88, we'll say, well, 88 is almost 90, which is halfway between here. So I'll say something like that. And then 2550. Well, 50 is going to be between 40 and 60. And then 50 will be between 40 and 60 again. Oh, excuse me. 25 will be between 20 and 40, a little bit less than halfway. And then we have 50 right in that region. 38, 45, well, 38 is really close to 40. 35, somewhere in that region, a little bit less than 40. Then 41 and then 33, so 41 will be really close to 40. 33 will be almost halfway between the 20 and the 40, so I'll do something like this, really close to our previous point. 60 and then 19, well, let's basically pretend that that's a 20, right? 60, 20. 97 is almost 100, and then 21 is basically 20. So we'll say something like that. All right, number 4. All right, so my x's go from 1 to 9. So let's just tally them all 1 through 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there's my x's. Now for my y's. So y goes from 100 to almost 3 million. Maybe we could count by 500,000. So I'd have 6 intervals. So 1, 2, 3, 4, 5, 6. So 500, and I'm just going to put a K. This is going to be 1 million, 1.5 million, 2 million, 2.5 million, and 6 million. All right, starting off, we have 1 and then 100. Well, our interval here goes between 100, or goes from 0 to 500,000. So 100 is going to be really close to the axis. It's going to be really far down there. 2 and 450, same thing. It'll be above the other one, but not by a lot. Even with the 2,300, it's still very close to the bottom because we're going all the way up to 500,000. So 4 and then 2, 3, so still kind of like that. 6 and then 65,000, still really close to the bottom. And then for 9, we have two different ones with 9. We have 1.1, we'll say 1.2 million, so it'll be somewhere in that region. And then we have 2.9, we'll say that that's almost 3 million. Why did I do it this way? Oh, that's not supposed to be a 6 there, that's supposed to be a 3. Oops. It's all the way like up there. All right. So that's that. Whenever you're looking at these, I think that the hardest or the most time-consuming piece of it is just drawing your axes and deciding, well, what am I going to make my intervals be? Remember, there's no wrong answer there. It just has to be able to fit on a piece of paper. So you can be as precise or as not precise as you want to. Whenever I go up here and I did my interval of 500,000, that's not very precise because if you were just looking at this graph and I told you, well, what does this point mean? You wouldn't really know. Or if I told you, what does this point mean? You wouldn't be able to give me an exact data point for that, right? So in a sense, we do lose some information whenever we graph these like this, but they can be good visual representations, and that's what we're going to get on in the next section.